Okay, it's very fitting that this is the final sheet of paper because this is our final topic. So, in this chapter, there's only one thing I didn't go over, and that was significant figures and conversions. That's such a basic thing that if you're taking fluid mechanics and you don't know your conversions or significant figures, like, honestly, I don't either. I can't blame you, but like your calculator has this app here. You just go to sig fig calculator unit converter, then you go to the SI prefixes, and this is everything you need to know. Base to mega, there you go. But with that out of the way, we've covered fluid properties, sliding plates, the appendix problems, which is like the it's even simpler than fluid properties. You just need to know what you're looking for, and then it's in the appendix at the end of the book or start of the book. Now, the last thing we need to know is the fluid height with, like, I guess a meniscus, fluid rising, kind of like I have an example. We got like two things here, like this, right? And say like the base of the fluid's here. Maybe it's just rising up along something. Okay, this is the basic concept here. This is going to be problem number 60. And what we have is mercury sitting in a bowl. Ooh, it's the opposite actually. Let me redraw this. So same concept, but this is a little bit more interesting. So we've got this here, this here. Here's our pipe going into the water. The mercury is actually below the water line this time. That's the only change here, is the H is going to be taken from this down instead of up, but it's the same thing. And there's also a diameter here, which E equals 0.12 inch, and temperature is 68 degrees F. Now remember the equation here. If we go to our... Oh, and there's one more thing. This angle here, 50 degrees. Sorry, almost forgot that. So if we go to our little equation chart here, this is the height we're looking for. This is the equation we'll use. So the solution here is H equals 2 this stress, which we aren't given outright. This is going to be shear, I think shear strain. This is, surface tension and capillarity. Usually we're given this, what do they even call it? They just call it like whatever the symbol is. Cosine theta or whatever. And that's going to be rho g r. So we know this angle, we know radius, we know gravity, we know it's mercury, and we know the 2, which means all we have to figure out is the stress, and we can get the height. So this is a tabulated value, it looks like. We go in the book and go to Appendix A, which is right at the back, and look up the properties of fluids. Mercury, has a surface tension right here. This is surface tension. So this is a little bit of an appendix problem, is 33.3 pound per foot. So now we know everything. So let's plug all our values in. It's going to be 2 times 33.3 cosine of, I think it is measured from here. No, it isn't. It's 180 minus 50. So that would mean if we're starting from here, subtract 50. Well, I guess that's where they want it from, is here. First quadrant vertical. So I guess remember that if it makes any difference at all. And then the right here, density. I can call this mercury. Density of mercury is 26.3 slug per foot cubed. Gravity, I'll just might as well write everything out. 9.810. That's meters per second. It's 32.2 feet per second squared. This is all in imperial units, so this is going to be 26.3, 32.2, and then R is going to be 1/2 D, which is 0.12 over 2, which is 0.06. Putting all of this together, H equals 2, 33.3, cosine 180 minus 50, 26.3, 32.2, 0.06. Oh, forgot one thing. This is in inches. We have to convert inches to feet. Divide that by 12. Oh. My apologies. This, in the appendix, it's e to the negative 3. Small correction here. E to the negative 3. There it is. Negative 0.0101 foot. Or, to keep better significant figures. So sorry about that. My mistakes were pretty much just rushing through the appendix and remembering that this was in inches and everything else is in feet. So you need to make sure you keep all of that the same. You can't have some in inches, some in feet, you know. Yeah, that's it. That's the problem. Sorry for the small mistakes. This is actually my last paper, so I can't redo this. I hope this was helpful. So, yeah. Peace.